shall we start right now? Because
Sure.
okay, that's better. Alright, so I'm Lishi, I'm the TA of this course, and today we're going to talk about the scikit-learn toolbox. So this is what I'm going to talk about. First of all, I'll introduce how to install and a brief introduction of the background of this toolbox, and then I'll introduce how to load data, some basic stuff of the I/O streams, and then we'll include some basic models, and then we'll have a demo, and in this demo we will cover this point bullets. Right? So before we start, so may I ask how many of you have already have hands-on experience on scikit-learn?
I did massive.
Yeah, sure.
Yeah.
So how many of you are familiar with Python? Yeah, that's really okay. But don't worry, Python is a kind of a straightforward toolbox, and scikit-learn it's a good starter for like the statistical analysis to handle the machine learning techniques. And this page covers the benefits and the potential drawbacks of this toolbox. The first I want to emphasize is the consistency, because I will going to cover the basic steps for training a model, and you can see if you change the name of the model, the basic steps, actually there are 4 steps. They are exactly the same, so it's easy to follow. So I think it's the best feature of this toolbox. And I'm going to talk about how to turn the hyperparameters of the models, and scikit-learn just give us a kind of a they just release the pain of manually turning the parameters. They have a kind of a highly automatic way to do that. And the last but not the least, the documentation is terrific. So if you have any questions, you can look into the details. And the potential drawbacks is comparing to R, but since we are going to consider to use TensorFlow in our later homeworks, maybe we should add some lines in this part. Actually, I think one of the major drawback of the scikit-learn is that we cannot manipulate the model itself, because it's already embedded into the system.
Mm-hmm.
So if we want to use something more advanced like TensorFlow, it's more convenient to modify the layers of the neural networks, something like that. So if we are going to get a publication or something like that, so maybe we can start from TensorFlow. Or recently there's a new Python release of the, it's called a PyTorch. Have you ever heard Torch, right? Torch is a classic deep learning toolbox, and previously because it's written not in Python, it's not straightforward. But currently they have a new release, and I'm looking forward to test it out. But I don't think it will outperform than the TensorFlow. So maybe if you are considering to enter the business of the deep learning area, maybe TensorFlow is the best choice for now, based on my understanding. And for this task, I'm going to use the IPython notebook. It's a kind of because it's easier for demonstration, and you are not necessary to use this kind of a toolbox. You can use Python directly, and you can use whatever IDE you're used to. And as you can see, the IPython notebook, basically IPython is interpreter, and iTensor Notebook is like a browser IDE. So in that way, you can add it. First of all, it's a cross-platform, and second, you can extract PDF files or Python source code, or actually there are multiple choice, and it's easy to like extract a report or a code. So yeah, and it's a kind of online, so it's a good way to demonstrate. So there are multiple ways to install scikit-learn, and what I'm recommend is use a third-party distribution. I'm currently using the Anaconda, and I highly recommend you to use this, like the toolbox. It's a kind of a combination of maybe all of the necessary dependencies you are going to dealing with. So if you have already and it works for currently I'm working on Windows, and it has different implementations. So once you have finished the installation, the good feature for the Anaconda is that you can run your script in virtual environment. In that way, you won't mess up your other configurations. So for this class, I built up. Actually, you can use. I will show you. In order to create a virtual environment, you should use a command line like this, conda create, and you don't have to do this one. It's short for name, and you can name your virtual space, and you can define the current Python version. And as you can see, you can define different Python version for different virtual environment. And for this one, a little bit slow. Oh, it's already inside. So.
Can you open this? Can you increase the character size
Okay, let me
in the
try.
command?
guess the size of the
When you open up,
Apologies.
yeah, when you open up
Six.
the command prompt, when you open up the command prompt again, can you open it up?
yeah, I'm
Yeah.
it's library.
Oh, yeah, oh, thank you.
Yeah. Is it better?
Oh, yes.
Yeah, once you have create that virtual environment, you can activate using this command and deactivate use this command, right?
And this is the virtual environment of scikit-learn?
It's a kind of it's more like a virtual machine, and all your configuration are inside that virtual machine. It not influence your like overall configuration. So in that way, you cannot mess up with your computer. So, yeah. And all you need to do is let me close that first. IPython notebook, and it will open up a browser, and as you can see, you can where is it? Okay, new. Basically, you just create a virtual environment for Python, and you can add it right here. And let's see. And you can add each of this structure called a cell. And each cell, there are two types of cell. One is executable. Another one is more like notation. Voids. And you can type Control and Enter to execute that. And you can as you can see, it's you can put one line and you can put multiple line here. And something interesting is that it's not executed from top to the bottom. So I would say you might want to like to avoid this happen, because when you submit your homeworks, it's better to download as a Python file inside of a Python notebook. In that way, I can execute it on my side. And besides, you can download it as a PDF, and you can like merge the paragraph with your report, and I think it's kind of an easy way to do that. All right, let's close this. Before we close this one, as you can see, the green ones are currently running. So if we want to terminate that, we should go here, close and out, or here, just terminate the kernel. And then you can see it's not running right now. Okay, here is what we are going to talk about. So first of all, if we want to start a machine learning process, the first step is to get the data set ready, right? And the good thing of the scikit-learn is that they have some tiny built-in samples, and they call it toy libraries, toy data sets, actually. And since our homework is about a classification task, so I'm going to use Iris, for example, for our task. And actually, our task is more related to the digit task, and I will come up to that later. And for the Iris dataset, okay, so for the Iris dataset, it's a kind of a numerical dataset. All we have is 4 features. They are pental length and width, spectral length and width, respectively. And we have 5 samples in total, and we have 3 labels. That means they have 3 different species. So the first step is to load this dataset. It's pretty straightforward, and it's similar to other languages. And we can just load this, and as you can see, if it turns to numericals, it means we have already executed in the backend. And we can see the type of this dataset. Since we can see the type because it tells us it's already in our folder, right? And they are the names of the features, and they are the label vectors. The name of the labels, respectively. As you can see, the data structure of this type is a NumPy array. So what I want to emphasize that scikit-learn training algorithm just support a specific type of input. This data set should be, for the features, it should be a feature matrix, of NumPy array. It's NumPy matrix actually, and the labels should be a NumPy array. And the altitude of these two matrices should be the same. I mean, the rows, right? As you can see, we have 115 samples, and each feature vector consists of 4 features, and we have the labels of them. So, well, I think last class we talked about the supervised learning, and there are two kinds of supervised learning. One is the classification, when we are dealing with categorical labels, and another one is regression, when we are dealing continuous scores. And today we are going to dealing with a sample of the categorical classification. So scikit-learn has a rich set of built-in functions, and where's my cursor? Okay. They are the main sets for the classification method, and this is for the regression. They also support for clustering, which is unsupervised learning, and dimensional reduction, basically for like statistical analysis. And they have some code functions to support the whole chain and link them together. Where's this one? Alright, since we have already load that data set, we can name the feature matrix as X and target as Y, right? And if we have some new observations, we can just come up randomly, something like that. So let's start from very basic classification function called the logistical regression. It's kind of confusing because it names regression, but actually it's a classification method, right? I think we have already covered the part in class, so I don't need to go to the details of the mathematical. And as you can see, all of these models are in the scikit-learn models, and for this linear model, it's inside the linear model subfolder, and you can import in that way. But you can also import this whole stuff. Yeah, but in terms of time complexity, we should do that way. We should always do it that way. From some subfolder import API. And this is the first step of the 4-step loop of the training of the training process. And second step is to get an instant, right? So we use the default parameters, and this is what we got for our training model. And then we should use the third step, which called the fit. It's running on the training set, and the fourth step is testing. We call it predict, and it's running on the test set. you can see it's pretty fast because it's a tiny data set and it's a pretty simple method. And these are the labels of the prediction. What is, okay. Okay, got it. And then we should try something a little bit advanced than the linear model, right? So we have introduced a nearest neighborhoods method in class, and here we are going to use the standard k nearest neighborhoods. Basically, it's just get the voting of the most k most nearest eigenvectors, and then to get a majority voting to get the predict label, right? So as we can see, the first step is to import. And this subfolder called the neighborhoods, and this API called k near neighborhoods classifier. And then we got an instance, and we can set up some parameters here, and we can set as we can see, for this one we have a bunch of hyperparameters, and for this one it's the same. And then we should try this training called fit and the testing called predict as well. As you can see, the result is different, right? So the question is, since we just randomly couple with the new observation, we don't have the ground truth label. So we need to find a way to make sure which model is better. Actually, in this case, which model is correct, right? So that's what we just talked about in the previous hours. We need to find a way to get the ground truth and to test the performance of this model. And then we should use train test splitting techniques. Basically, scikit-learn enable us to split the training and set into two sets, and the default rate is 0.75 for the training. It doesn't matter because it's something related to the version of this scikit-learn. They will just get something more powerful in the later release, but currently we can stay on it. You can see that the train test split function is inside the cross-validation suborder, and train test split just receive like these two. These three. Actually, these two are necessary parameters, and we can also set. The first one is the training. Is the feature matrix, and the second one is the label. And we can set up the splitting rate. It's the size of the test subset, and by default it's 25%. And we can also set up the random state. I want to emphasize on this because the number, it doesn't matter, but I want to add one more line on this parameter because it's you know that computers just generate a pre-compute fake random numbers, and if you just put this number here, and you can run multiple times, and it will get exactly the same result. So if you want to compare your training result or compare different models, it's a good strategy to use a random state and use the same number. And we've got our splitting, and the shape of the training is 105 and the testing is 45. So since we have got the splitting, so maybe we can modify our original code. So any volunteers? So which part do we need to modify?
Well, we are not going to modify key for nearest neighbors because we don't need labels. So we can just modify, instead of saying key neighbors classify and neighbors equals 10, KNN, it should be X basically.
Yeah.
Fit, so instead of X, is it already taken out?
So instead of X, it will be X train and
Right.
Y
Yeah.
train and
Yeah.
prediction.
So what about the prediction,
So that
predict
will
function?
be X test,
Right.
test and
Exactly. So we can just copy this part. No, I don't know, just typing. Is that correct? You all great? Okay. Let's try it. Alright, so for now we have got the labels. And then we should find a way to evaluate our model. And the most straightforward metric is classification accuracy. And Scherer has a rich family of the matrix, and it's all inside like subfolder called matrix. And since we've already got the Y test and Y predict, by the way, all the information is lying in the background, so we can use that across cells. So since we have already got Y test and Y predict, and we can get the overall accuracy. Right. And as we talked about this before, it's more powerful like a measure is confusion matrix. And for binary classification task, the Scherer has some built-in functions called recall and precision, as well as the confusion matrix. But they don't have the built-in false alarm rate and miss rate, so we should calculate by manually, right? And another matrix is F1 score. It's calculated from based on the binary, based on the confusion matrix. But for here, actually, it's not a binary classification. We have multiple. Yeah. We have multiple labels, so it's a multi-classification. But actually, this computer matrix API is quite powerful. It just doesn't make a difference. So as we can see, I would say it's pretty good. I mean, for the result. And F1 score normally just support binary. Okay, I'll add this part later on. Just ignore that part. Yeah. So that's basically the most basic version of the training process. And then we should look into some details about the model itself. As we remember, we have input a hyperparameter. When we define this classifier. So what if, we need to find out what is the best parameter for this specific task, right? So this kind of a technique is called parameter tuning. And we can just write a simple for loop to get for one hyperparameter, we can just use one loop for loop, right? So I'd like to test k from 1 to 20 for here. And as you can see, for Python, you need to write 21. You should plus 1 here, right? So just a loop tree. And you can see the peak is around in the middle, right? But it's not kind of straightforward. So we might want to get a better visualization. So then we should use a library called MATLAB, and it just generates basic plots and a box plot, what we are going to use in the homework, and something more advanced. We can cover that later, and you can check that in the document. The online website. They have a. And now we can see. The y-axis is the accuracy. So for the kn, for this specific model, the larger n means the model will be simpler because you can see that if we just have two classes, the boundary of this class should be fluctuating, and if we have more, it's more smooth. So in that way, we should choose this one. It's almost, I think it's around 13. Okay. So I think I can skip this part because we already covered the k-fold. Yeah, sure. So a better way to do this is to use a cross-validation, k-fold cross-validation. It's also inside the cross-validation folder, and it calls a cross-validation score, and we will get the same error, warning. And for here, 10 will always be a kind of a good choice for a starter. So for here we'll try 10-fold cross-validation. And previously we said k equals 10, and we will keep the same, but we can change that. And as you can see, the function called the cross-validation score. And the first input is the neural network, the classifier itself, and then the feature, and then the label, and then the folder number, the number of folds, and then we are going to use the score. Currently, we're using accuracy, and we'll come back to this later. And for this ones, it's probably overfitting. But generally, it's good. for the train test splitting, we have already come up with the parameter tuning code, which is a for loop, and it's basically same and here, and actually it's simplified. As you can see inside the for loop, we can just use this instead of the prediction. And we can see the best performance is around 20, right? So for your homework, we'll probably start from the cross-validation. And there are some way to improve the cross-validation result to make it more stable and more accurate. And the first one is repeat the cross-validation. Because, something I should mention is that maybe I should ask you first. So since we've already talked the skewness of the data set, so one potential issue with the data splitting is that it's not split equally, right? I mean, for the, let's say we have even if we have 50% of label 0, 50% of label 1, if we split into 75% training and 25% testing, it might not equally. So in that way, we should come up with strategy called the close that table. Yeah. I will find it later. But my point is that for scikit-learn, we don't need to worry about this. At least for the cross-validation function, it's already handled by itself. But for the test splitting function, it doesn't. So it's a good start to use the cross-validation function. And then if you take this, the CSCI 353 before, you might remember that we asked to hold out some data. And not just, we can use leave one out, but we can also use the hold out strategy. In this case, the test data is always untouched. And we just manipulate the rest of the data and validate on that part of the data. In that way, it's better for the out of sample accuracy. And then, if you are familiar with SVM or something like that, you will probably dealing with. If you have multiple features, you will probably get a lower accuracy than some best features as a feature vector. So here it comes with the feature engineering techniques and feature selection. For the feature engineering, basically it's related to the feature normalization or something like that. And if we have a picture as an input or image as an input, we may be downsampling that to unique matrix, or we need to use a filter to get it blurred or something like that. So that's called feature engineering. And since this class we're dealing with multiple channels. Like we are going to combine the video channel with visual channels. I mean audio and video. So there's a synchronization issue. So if we want to use early fusion strategy, that means we combine this feature together before we train the model. We need to get a kind of a unique, uniform sample rate, right? So this all falling into this category, the feature engineering. And the feature selection, as I mentioned before, if you just throw in all the features, it might not get the best result. You might carefully select the most significant features, and the best way to do that is to get that during the validation phase. And one more thing about the feature selection is that if two columns, two features are heavily correlated to each other, or multiple features are correlated to each other, it's better to just select one of them, or other information will just be the hidden information because it will just dominate the classification task. So there are some tricks inside the scikit-learn, and we can use that, but if we heavily rely on it, it will, I mean, it's nothing left to do, actually. So it's called the grid search. Basically, it's a combination of the parameter tuning and cross-validation. And you can see the same warning, but it doesn't matter. So, the fundamental, the core part of the grid search is that besides the model, the classifier itself, and the vote and the scoring function, there is another parameter called the param grid. It's a kind of a dictionary of the labels, and we can set up a range. No, it's not labels. It's attributes per se. As we can see for the kn, the k neighbors could be attributes of this classifier, and we can have a range of this. And basically, the training and testing function are the same. So one more interesting part about this function is that it supports different multiple parameters in one round. So you can optimize this hyperparameter simultaneously. And you can see the parameter grid consists of two parts. The first part is neighbors, and the second part is weights. Oh, never mind, I just... That costs just a support for one parameter, but it will get the same. in that case, we should try a 3 function in terms of plotting. But it will be another story because this plotting toolbox doesn't support that advanced feature. If we want to 3 plotting, we need another toolbox, but currently I don't have that on my machine. And one sweet point of the CV grid is that we can get the best. It's already stored here. We can get the best store, best parameter, and the best estimator here. And as we can see, the best hyperparameter of the K is 13. So we can just train our model use this hyperparameter. Actually, since this grid is our classifier, it's already updated to its optimal. So actually, if we want to like plot the metrics, it's already got the best performance. So that will be terrific for kind of automatic training. So one more thing about the regression method. Previously, we just covered the classification tasks, and our homework is about classification tasks. But here, I'd like to mention that the metrics of the classification task doesn't apply to the regression, right? Because the accuracy doesn't make sense, and we cannot get a confusion matrix. So in this case, we use mean square error and root mean square error. And this is a built-in function in scikit-learn. It's still in the matrix and called the mean square error. And the input should be the true label and the predict label. And since the root mean square error is more popular in the publication, maybe we should just manually add the square here. And that will be all for the basics. And I have some additional, but do you have any questions for now?
Are you going to post the code?
Yeah, definitely. But it's nothing related to the homework.
It doesn't matter.
Yeah, sure. Yeah, I just skipped that part because we've already covered that part in class. So firstly, Stefan was interested to let us to do some tasks on the MINIST dataset, but actually it's a little bit large. I mean, in terms of the training, maybe it will be time-consuming. And the good news is that the scikit-learn has a built-in function, a built-in dataset called the digits. It's probably the same. You can get some insights about this one. Yeah, this training, and basically they are just 20 plus 20, I guess, or 12. Yeah, let's see 20 plus 20 for now. Yeah, it's just a small image, and the label is the character. So it's a 10-class classification task, and each of the input is the image. And you can come up with a confusion matrix or something like that. Actually, they already have the baseline here, so maybe you can come up with something fancy in terms of visualization. Yeah. The last thing I want to talk about is the ROC curve. Since there are already 2 minutes left, I will go through it very quick. Some instance about it, ROC curve is something like that. Basically, it's if we imagine a two-class classification task, never mind. Just use code. One more thing we could manipulate is that we have the prediction is not just a label. It's actually come with a score. The prediction, we can get the prediction score by calling a function called I can just type it here. Drop. Something called this. Instead, use a prediction to get a classification, to get the category classification label. We can get a probability of each class. So in that case, for the sake of simplicity, we can just imagine a two-class classification, right? So by default, the threshold is lying in the middle. It's 0.5, but we can adjust this threshold, and then by adjusting that, we come up with this. You can see that the true positive rate and false positive rate, right? Actually, it's from 0. Just move the threshold from 0 to 1. So in that case, we can get something like that, like this. And since we got the ROC curve, we can get this area. And I mean, this area is the area below the curve. The larger the area is, and the better the model is. So one last line for this is that we can modify this part to ROC curve, just scoring, right? Okay. And that will be all for today. So any questions? Yeah.
Will the code just be posted on Blackboard?
Yeah.
Okay. Thank you.
So what's it homework? To recognize the digits from the digit set?
Yeah.
Yeah.
The inputs are image, but the output should be the.
I was trying to type it out.
Yeah, it should be the
And
text.
what classifier should we use? Whatever we like.
I
we should try several, right?
Working along
Start
with,
from
like, the
SVM,
examples,
Uh-huh,
'cause,
start
like then
several
I know like
Yeah.
if I'm
And you can
to, like,
also
at
try
least know, like,
the
a baseline.
like neural networks. We have the MLT inside this toolbox,
Okay.
and you can also build deep neural networks by scikit-learn, but it's kind of
Priyanka.
frustrating, but you can definitely have a try. Okay. Yeah.
Cool.
Thank you very much.
So it's cool for you. It's cool for you. It'll work for you.
Say hi.
Okay.
But like, I don't know, we can
Priyanka.
kind
Green,
of
yeah.
come up with.
Yeah, it's on this, 'cause he was like,
what we need to submit the project.
Who wants to submit a file?